Good morning, dear students, and welcome back to online video lessons. I hope that you all are doing well. We will continue with Chapter 3 Atoms and Molecules in Chemistry. We already discussed about the properties of atoms and have started with the study of molecules. As we consider atoms, it is the basic unit of a chemical element. Atoms are the basic building blocks of element and the matter around us. An atom itself is made up of three tiny kinds of particles called subatomic particles: protons, neutrons, and electrons. When we discussed about the molecules, molecules form when two or more similar or dissimilar atoms form chemical bonds with each other. Molecules form when two or more atoms form chemical bonds with each other, and it does not matter if the atoms are same or are different from each other. Atoms bond together to form large particles called molecules, and molecules join together in different ways to form matter and different substances around us. Examples of molecules. If we consider oxygen, hydrogen, carbon, nitrogen, chlorine, fluorine as the atoms, these atoms combine in different ways to form different substances around us, which can be elements, which can also be compounds. Like for example, carbon and oxygen atoms combine to form carbon dioxide gas. Carbon and hydrogen atoms combine to form methane gas. Carbon along with fluorine and also again another carbon atom when combines to form chlorofluorocarbon, whereas nitrogen and oxygen combines to form nitrous oxide. Hydrogen and oxygen atoms combine to form water molecule. As these four are the examples, five are the examples of compounds, we see ozone. The ozone is the element in the gaseous state formed by three atoms of oxygen. So the atoms combine, which can form the compounds, which can form the elements bonded by chemical bonds. A molecule is an aggregate of two or more atoms in a definite arrangement held by chemical bonds. Later on, we have to study about these chemical bonds also and how the atoms are combining. When we consider a molecule can be monoatomic molecule or can be polyatomic molecule also. In case of hydrogen gas, water molecule, ammonia gas, and methane gas present here, we see more than two atoms present, and therefore these molecules are polyatomic molecules. A diatomic molecule contains only two atoms, such as hydrogen gas, nitrogen gas, oxygen gas, bromine, hydrogen chloride, carbon monoxide, whereas a polyatomic molecule contains more than two atoms, such as ozone gas, water molecule, ammonia gas, and methane gas. What is the difference between a compound and a molecule? A molecule is formed when two or more atoms join together chemically by chemical bonds, whereas a compound is a molecule that contains at least two different types of atoms. So all the compounds are molecule, but not all the molecules are compounds. We therefore have molecules of elements and molecules of compounds. Molecule of hydrogen is formed of two hydrogen atoms. A molecule of oxygen is formed of two oxygen atoms. A molecule of chlorine is formed of two chlorine atoms. Whereas a molecule of water is formed of two hydrogen atoms and one oxygen atom. A molecule of hydrogen chloride is formed of one hydrogen atom and one chlorine atom. Some of these molecules are also in the air. Some of these molecules are forming the solid, and some of these molecules are forming the liquid too. We will consider a few examples of molecules in the gaseous state or air molecules, such as water in the form of water vapor, nitrous oxide, carbon dioxide, ozone, methane, chlorofluorocarbon, CFC. Apart from this, nitrogen gas and oxygen gas, hydrogen gas a bit or in a very small quantity also are in the air or air molecules. Now, as we consider the molecules, we will see first molecules of elements. The molecules of an element are composed of identical atoms or similar atoms. For example, an oxygen molecule consists of two oxygen atoms and a nitrogen molecule consists of two nitrogen atoms. Therefore, a molecule of nitrogen and a molecule of oxygen are called diatomic molecules. This gives us the idea of atomicity. The atomicity of nitrogen and oxygen is 2. When three atoms of oxygen combine to form a molecule of ozone, then the atomicity of oxygen is 3 in ozone. So we can define atomicity as the number of atoms constituting a molecule. We do have different types of molecules on the basis of atomicity. Monoatomic molecules, diatomic molecules, polyatomic molecules. Helium, lithium, krypton are monoatomic molecules. An atom of each is sufficient enough to remain independent and also are free. Diatomic molecules. Two atoms of particular element form a molecule and are independent to show the characteristics. Polyatomic molecules will have more than two atoms, similar or dissimilar type, to remain independent, to take part in chemical reaction, as well as to show the specific chemical properties or characteristics. Monoatomic molecules for elements are the group of inert gases and also of metals. For the group of inert gases, the atom and the molecule are equivalent. We say that these substances contain monoatomic molecules, like for example, helium, neon, argon, krypton, xenon, radon. Now, why we call these gases as inert gases? These gases do not take part in chemical reactions. These are non-reactive and therefore are known as inert gases. The diatomic molecules include hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. represented by H2, N2, F2, O2, I2, Cl2, Br2 respectively. The representation of the composition of a molecule of the substance in terms of the symbols of the element present in a molecule is known as a chemical formula. So H2, O2, I2, Cl2, Br2, H2O, NH3, CH4 are the representation of the composition of a molecule of elements and compounds, which include the symbols of the elements present and are chemical formulae. A chemical formula is also known as a molecular formula. The chemical formula of an element is a statement of composition of its molecule in which symbol tells us the element and the subscript or lower figure tells us how many atoms are present in a molecule. Let us consider the formula of sulfur. It is S8. So we can say that this statement gives us the composition of its molecule, sulfur molecule, in which the symbol S tells us the element sulfur and subscript 8, lower figure 8, tells us that 8 atoms are present in a molecule. The inert gases like helium, neon, argon, etc. are monoatomic. Similarly, the metals like sodium, potassium, lithium, magnesium, aluminium, zinc, etc. are also monoatomic. So their symbol and formulae are just the same. All the metals in fact are represented by their symbols and they do not have any separate formulae. This table gives us the idea of molecular formula of some common elements. Of hydrogen, the formula is H2. So hydrogen gas, whenever it's been represented, we do use the chemical formula H2. Nitrogen molecule is represented by N2. Whenever we do discuss nitrogen gas, we do consider the chemical formula N2 to represent it. Oxygen molecule is represented by O2 as its chemical formula. The chemical formula of chlorine gas is Cl2. The chemical formula of bromine is Br2. The chemical formula of iodine is I2. The chemical formula of phosphorus is P4. The chemical formula of sulfur is S8. If we have to find out their atomicity, we can say that the number of atoms in one molecule gives the atomicity. The atomicity is 2 for diatomic elements present here such as hydrogen, nitrogen, oxygen, chlorine, bromine and iodine. The atomicity is 4 as phosphorus is having 4 atoms in its molecule and therefore is the example of polyatomic molecule. The atomicity is 8 of a molecule of sulfur as 8 atoms are present in a molecule. It is also the example of polyatomic molecule. So in our next class, we will discuss about the chemical formula of compounds. We will discuss about molecules of compounds in detail. Thank you.